Hey guys, welcome to another Swift deep dive. And in this deep dive, we're going to learn more about using optionals. Now, previously, you've already been introduced to our ill-fortuned cat, Fluffy. And because of our lack of understanding of optionals, we put her life in severe danger. So how can we make sure that we're not getting calls from the animal rights people and make sure that we treat our cat properly? Well, let's see how we can keep her out of harm's way. So what's going to happen in this deep dive is I'm going to walk you through 5 different ways of working with optionals in Swift, including force unwrapping, checking for nil values, optional binding, the Nil Coalescing Operator, and optional chaining. So that's a lot of new words, but let's get started. So I'm going to go ahead and create a new Mac OS command line tool, just as we did before, and I'm going to call this optionals demo. And when I go to my main.swift, I'm going to delete everything that's currently inside, and I'm just going to use it as we do with our playgrounds. So first things first, I'm going to create a optional, so I'll call it my optional, and I'm going to give it a string data type. But of course, to turn it into an optional, we just have to add the question mark at the end. Now, notice how the string data type is actually completely separate from the optional string data type. So if I was to give my optional a value, let's say Angela, and if I create a constant which requires a string data type and I try to set it to equal my optional, this is not going to work because this expects a string and this has actually a completely different data type, an optional string. So how do we work with optionals? How can we turn it into an actual string that we can put into labels or buttons and manipulate in our code? Well, one of the simplest ways of working with optionals, as we've seen, is to simply just force unwrap the optional. But this, of course, requires us to really think hard and fast about whether if there's a case where we could be unwrapping the optional and it could actually have a nil value stored. Well, in that case, Fluffy gets it. In this case as well, if I go ahead and simply just unwrap the optional, then I make all the errors go away and I kind of am just telling Xcode that, you know what, I know better than you and I know that this is never going to be nil. But what if my optional was actually, in fact, storing no value at all? What if it was equal to nil? So in this case, yes, Xcode is not reporting an error, meaning we have no error at the moment. And our project builds successfully. But when I run my code, it crashes. So in other words, I experience a crash at what we call runtime. And it crashes on the line where I'm force unwrapping my optional because it was unexpectedly found to be nil. My optional was equal to nil. So this is probably the least safe way of working with optionals. It requires you to be really concentrated and search through your code to make sure that it can never be nil. So I know in this example it seems super obvious because we're setting my optional to nil 2 lines earlier. But what if you were working on a more complex project with many files and many lines of code that you can't always keep track of? Well, in that case, it will be a lot less obvious. So what else can we do? Well, a slightly safer way of working with optionals is to check to see if it's equal to nil. And if it's not, then we force unwrap it and use it in our code. If we had wrapped this line, which is crashing our app at the moment, inside an if statement where we check if my optional is not equal to nil, well, in that case, then we can use it. So now if I run my code again, then this line is just going to be skipped. How can we tell it's skipped? Well, we can write an else statement where we say, my optional was found to be nil. So now let's run it again. And you can see we get my optional was found to be nil. So this if statement was skipped, saving us from crashing our app. But here's a problem. This is firstly quite wordy. even though I've already checked to make sure that my optional is safe to work, I still have to use this exclamation mark to force unwrap the optional every single time. So if I wanted to create another constant, let's say text2, which was a string, and I wanted to be able to work with my optional, well, again, I can't simply just use it without adding that exclamation mark where I force unwrap it. So this behavior where we are checking to see if the optional contains a nil value, and if it's not nil, then we work with it, is so common while we're working with Swift optionals that there is functionality that's built into optionals to handle this, and it's called optional binding. So in this case, what we do is we can write an if let to bind the value of the optional, if it's not nil, to a new constant. And within the curly braces of this if statement, we can now work with this safe version of the optional, which has been unwrapped. So in this case, instead of writing if my optional is not equal to nil, I can write if let safe optional equals my optional. Well, in that case, safe optional is going to equal the value of my optional, but notice how safe optional has a data type of string while my optional is an optional string. So now if I wanted to work with the value of my optional, namely the word Angela, well, I can now simply use the safe optional. And you can see that if I decide to print my safe optional and run my code, you can see that I get the value that's stored inside my optional printed from the safe optional. So it's just a way of performing that action of opening up the box, seeing if there's anything inside. If it's nil, then simply go ahead and skip and go to the else statement. But if it's not nil, then we're going to put the value inside my optional inside this new temporary constant, which we can use inside the curly braces. But this simply just skips the optional if it's equal to nil. What if we wanted to provide it a default value in the case where my optional is equal to nil? How can we do that? Well, there's another functionality of optionals that comes in really handy right about now, and it's called the Nil Coalescing Operator. And it's simply just two question marks next to each other. And that's what it's called. And why is it the Nil Coalescing Operator? Well, because what it does is it checks to see if the optional is nil. If it's not nil, then we're going to use that value. But if it is nil, then we're going to use the provided default value. So in our case, currently my optional is nil, and I'm going to delete all of this if and else statement right now. And I'm going to try and again do the same thing, create a text constant that holds string data type, so real strings, not optional strings. And I want to work with my optional. Now here I can say my optional, well, if it has a value, then set that as the value of the text. But if it doesn't have a value, namely if it's nil, then we're going to use the double question mark, the Nil Coalescing Operator, and we're going to provide a default value. So I am the default value. And now if we go ahead and print our text, then you can see that because my optional was equal to nil, it was not set as the value of text. Instead, it's the default value after the Nil Coalescing Operator that was set as the value of text, and that's what's getting printed right now. So those four things that we saw, force unwrapping, checking for nil values, optional binding, as well as the Nil Coalescing Operator, cover all the cases where our optional is just holding a simple value. Now, there are certain cases where instead of having an optional value, we actually have an optional struct or an optional class. Well, what do we do in that case? Let's say that my optional is no longer just a string. Instead, I'm going to create a struct, which is called myOptional, and it's going to have some properties. So property equals 1, 2, 3, and some methods. So we have a method, which is just going to print I am the struct method. This is our very simple struct with a property and a method. Now, if I create a optional version, so my optional, and it's going to have my optional as a data type, but it's an optional. So I haven't yet initialized it. So if I wanted to actually turn it into a real struct, then I would have to say my optional equals my optional, and of course that set of parentheses will turn it into a real value. So that was the equivalent of giving the previous optional a value, right? It wanted a string. Well, in this case, it actually wants the structure to be initialized. In this case, if I wanted to tap into the property of this optional or the method of this optional, then how would I go about doing that? So let's say I wanted to print my optional dot property. What would actually happen in this case? Well, I can't, because this is an optional. So even though the property is not an optional, but because the struct is an optional, we can't actually proceed unless we either unwrap our optional, but if it was nil, then it's a little bit dangerous, right? Because if I turn that into a nil again and run my app, you can see that it's going to crash on this line. So even though the property itself is actually not an optional, it's just an integer, and we can see its value right here, we can't get to it if we haven't yet initialized this structure. So if it's equal to nil, then we can't proceed further. Now, how can we make this code safer? Well, then we would have to use something called optional chaining. So in this case, because our optional has some properties or methods that are accessed using the dot notation, in order to get to it, we add a question mark after the optional. And what this says is, if this optional is not nil, then continue along this chain and go ahead and access that property. And we can do the same with methods as well. So if the optional had an associated method, then only when it's not nil do we actually execute that method. So in this case, if we replace this exclamation mark with a question mark, then when we run our app, it won't crash anymore, but this won't be equal to anything either, because my optional is currently nil. So we can use this chaining method to access the properties and methods of our optional. And this means that if our optional indeed was in fact initialized, so it now does have the property and method set, then when we run it, it will actually execute that method. And it will print I am the struct method. So those are some of the 5 ways that you can use to work with optionals. And we're going to be applying that in our app in the next lesson. So continue to the next lesson, and I'll see you there.